Hi, in this volume of the Swayzer Video Library, we're going to look at the basic functions in setting up your TI, Texas Instruments Business Analyst 2 Plus calculator. Now, there's two calculators that are permitted for the CFA exam. One of them is the HP12C, the Hewlett-Packard, and then there's an edition of that called the Platinum Edition, I believe, which is essentially the same in functionality. And also this TI calculator. Now, if you're familiar with the HP12C and you know how to run it, then there's no reason for you to watch this, and we're not really worried about you. If you are new to the financial calculator or a lot of the functions, we really suggest that you get the Texas Instruments calculator. We focus on that. It's more intuitive. I've found over my years of teaching it's easier for students to use and catch on to. So our examples in the Swayzer notes, although we have some for the HP for specific functions, most of our answers and explanations and examples are based on the Texas Instrument calculator. Now there's a plastic one, and then there's this one called the Professional Edition. So since I'm a professional, Swayzer bought me this one some years back, and it has little rubber feet on it. It's a little heavier, has a better feel, and the buttons feel cooler when you press them. In terms of functionality, there's a couple of functions that are on this Professional Edition that aren't on the other one. Neither of them is very expensive, and as far as I know, they last forever, and never had trouble with one, never replaced a battery, although I guess it could happen if you were using it all the time. Mostly we use Excel these days, so they don't get used all that much, but you need to be familiar with it for the exam. So let's first talk about setting up your calculator. Okay. Now there's a key, there's second functions to a lot of these keys, and you'll see what's written over the actual key itself. Across the top row you see that says quit, set, delete, insert, all that sort of stuff. And those are the second functions. So first off, we want to set the number of decimals. I set mine to 4. The reason I do that is if I get a 4-place decimal, then I'm getting, 2 places in percent, right? If I get 0.0522, I know I've got 5.22%. So my accuracy, or my precision, I guess I should say, is to 1/100th of a percent, 1 basis point. And that's usually, I think, adequate for anything you're going to face on the exam. Now the calculator itself is carrying, I forget, 7, 8, 9 digits in its brain, and they're always there. You're not changing or rounding anything except what's in the display. So if you're using 4 decimal places and you get to a problem where for some reason you need the 5th and 6th decimal place, you can just go times 100. It'll move that over, it'll move the decimal point, but you'll see those next 2 digits just that easily. So use that second key and find the format key. That's the second function for the decimal point in the middle of the bottom row. And if I do that, mine reads dec equals and then 4. Okay. If you want something else in there than what you have, then put it in, put 4 in, for example, and then press enter, and then you can clear the display, and that's how it's going to display all the time after that. Next, we need to set payments to the end of the period. I think that's the default on the calculator when it's new, although I'm not sure. It's been a while since I had a new one. But use that second key and then the begin key. Now, that is right above the payment key in the 3rd row. So if I go second and then hit that payment key, mine says end, so I'm not going to change it. If yours says begin, then press second and then press that set button. It's actually the enter button in the upper left corner there, and that'll toggle between beginning and end. When it's in begin mode, there's a little BGN that shows up in the upper right-hand corner here and lets you know you're in begin mode. If it's in end mode, since that's the default, there's no indication of that on the display. So what you're essentially telling it, if you tell it, well, there's 4 payments in this annuity, a little short 4-payment annuity. In end mode, it assumes those payments, deposits into the account or payments out of the account, are made at the end of each of the next 4 years or periods. If you put it in begin mode, it assumes that each payment comes at the beginning of those periods. So the first payment would come today, which is the beginning of the first year or first period. Now we need to set up the number of payments per period. I think you should set it to 1 and just leave it there. If it turns out to be a monthly payment, we'll use the monthly interest rate. And N will be the number of months. If it's quarterly, why, we'll use a quarterly interest rate. N will be the number of quarters. Our payment will be payment per quarter. So really it says I over Y, but think of it as payments per period. And then we'll just think in terms of whatever periods we have in the problem we have to deal with. So use the second key and then hit I over Y. The display will read payments per year or payments per period equals, then press 1, enter, and then you can clear the display again. Now there's two modes of operation. One is CHN, which I assume stands for chain mode, and AOS, which has to do with the order of algebraic operators. Now, take a look at this calculation here. And let me find my magic teaching pen here. And I'll underline this. We're looking at this right here. And so you understand how the difference between these two, just look at the different answers you would get. Now, if we put in 3 plus 5 times 4. So this is what we're putting in. I'm not putting in any of the parentheses. So if I just put in 3 plus 5, when I hit times, that also does an equal function in chain mode. So 3 plus 5 is 8. I hit the times, and then you'll see 8 in the display. Enter 4, enter equal, and you'll get 32. Now, if you are set to algebraic operations priorities, then it goes 3 plus 5 times 4. Well, the order of algebraic operations, if I remember, is exponents first, and then multiplication and division, and then addition and subtraction. So since this times multiplication operator takes precedence, it multiplies 5 times 4 and then adds 3, so we will get 23. Now there are parentheses on this. In the middle there you can see a left parentheses and a right parentheses, and so even if you are set in chain mode, you can insert your own parentheses. So if I did 3 plus, and let me write this for you, well, if I were in chain mode and entered this with the parentheses, then I'd get 23. And when you close that parentheses, you have to hit the equal sign after that. Closing the parentheses would give you this value, 20, and then the equal sign would get you to 23. And you change those with that same format. If I go second format, I get my decimal, but I think if I do an up arrow, mine says CHN, which is where I want it. If you want it somewhere else, if you want it in algebraic operator mode, then press second and press that set key, the enter key, and that'll toggle between chain and AOS modes. Okay, so once we've got our calculator set up, now let's take a look at some of the keys on there. The reason I've got these 4 keys separated out here is because these keys all operate on the number in the display before it does anything with it. And I'll show you an example of that. Now, the usage of these is straightforward. If I put in 100 and then press that square root of x, it displays 10. 5, and then I hit x squared, I get 25. If I hit the 1 over x key, it gives me the reciprocal of that. So 5, 1 over x key gives you 1/5, displayed as a decimal as 0.2. And then, so those are all right across the 4th row there. And then at the bottom right, we have the plus minus key, which just changes the sign of whatever is in the display. So if we want to multiply times minus 5, then we put in 5, hit the minus sign, then hit the times sign. It'll be a multiplication sign. It'll be multiplying by that number in the display, minus 5. Let's take a look at an example here, and you can see here that these keys operate on the number and then it moves on. So look at that first example. If I want 0.89 divided by the square root of 2.17 times 7.3 squared, I just have to enter 0.89, then divide by 2.17, but before it divides, and that's the important point here, and it's really handy, before it divides, it'll take the square root of that. And then when I hit the multiplication, it's multiplying that, the square root, dividing by the square root of 2.17, and then times, I hit 7.1 or 7.3, but I want to square that, so I do that, and then hit equals, and so it multiplies by that 7.3 squared. Now, we could do this a different way. Sometimes when there's a lot of things going on in the denominator, it's easier to punch it in by doing the denominator first. So that's what I'm illustrating here. I can put in 2.17, take the square root of that, and then hit the 1 over x key, and then multiply by 0.89. Well, it's not much difference in work here, but imagine if you had a denominator that was 1.12 to the 7th power, then it would be easiest to do 1.72, y to the x will take it to the 7th power, and then hit the 1 over x key and then multiply by 0.89 or whatever's in the numerator. So that's just a handy trick, so that I think one thing you want to try and avoid is writing down any interim results. When you write down an interim result and then have to put it back in the calculator, there's always a chance for exam taking error, dyslexia to take over, or whatever gremlins are in your head at the time. So the less you do that, the less chance there are for making mistakes. So I try and do the calculations all kind of in a row within the calculator. If you have to save something, we'll talk about saving something in the memory function here in just a bit. Okay. So for 2 times minus 3.5, 2 times 3.5, change the sign to minus 3.5, and then equals to get the answer of minus 7. So a little bit of practice and you'll be very comfortable with these. Okay, I mentioned taking something to the 7th power, and we can't do that with the x squared key. With the x squared key, you can get x squared. If you press it twice, you can get x to the 4th. If you press it 3 times, you can get x to the 8th. But for these other exponents, we're going to have to use the y to the x key. So here's our example. We want to calculate 1.75 to the 5th power. So we enter 1.75 and then hit that y to the x key. It's just above the 9. And so you hit the y to the x key, hit the 5, and then hit equal, and that's what it gives you. It gives you 1.75 to the 5th power. So here's an example of how we might use that. The example here says a firm's dividends have increased from $2.21 to $3.54 over the last 4 years. Calculate the annual compound growth rate of dividends over the period. Well, first, if we're going to say, well, we've got 4 periods of growth, then we're going to use the 1/4 power here. We're going to take the 4th root. So 3.54 divided by 2.21, we want to take that to the 1/4 power. So what we could enter is y to the x, then enter 4, then enter 1 over x. Your display will change to 0.25, right, which is what 1/4 is. And then hit equal, and we need to subtract 1. But we can find out that 4 periods of compound growth of 12.5% would get us from $2.21 to $3.54. Now, if it's pretty obvious what that fractional exponent is, as in this case, we know that 1/4 is 0.25, we could go 3.54 divided by 2.21, hit the y to the x key, put in 0.25, hit equals, subtract 1, and get 12.5% rate of compound growth that way. So that's pretty easy with 1/4 or 1/5. Even with 1/3, you can put in 0.333333, but if it's 1/7 or something like that, or to the 1/7 power, it's just as easy to put in 7, hit that 1/x key, and get the decimal equivalent of 1/7. Now, storing and retrieving results. You've got 10 memory registers on this, and we're going to store them using the STO function, the store key, and retrieve them using the recall key. And so every one of those digits on your keypad, 0 through 9, identifies a different storage register. So, for example, this is a problem derived from the dividend discount model, the constant growth model. And so, what we're going to do here is do it in pieces. We're going to take that first piece and go 1 divided by 1.13 equals, and then hit store and then 1. And that stores that in register 1. The next piece we want to do here is 1.1 divided by 1.13 squared. So now we're going to use that squared function right in line, hit equal, that'll give you your answer, and then store that in the second register, and we'll store that answer of 0.8615. For this third term here, I use the parentheses because remember I've got this in chain mode. And so I want to take 1.21 and then I want to divide that by 0.13 minus 0.05, 13% minus 5%. And then I want to divide that by 1.13 squared. And when I get that, I can store that in register 3 by hitting the store key, hitting the number 3. And that will store 11.8451. Just as an aside, you notice that 1.21 divided by 0.13 minus 0.05? Another way to do that in chain mode is to go, let me turn it on here, 0.13, I can do this, 0.13 minus 0.05, and then hit equals, .05, hit equals, get 0.08, and then hit that 1/x key, and then multiply that times, what did we have here at 1.21, and then we can get that answer that way as well. And then we'd have to divide by 1.13 squared. So once we've got all these pieces, then we can just do, we've got in our display that third one, we've got 11.8451 displayed even though we've stored it, and then we can just go plus recall 2 plus recall 1 equals, and come up with 13.5915. Now, one reason you might want to do problems like that is say you're taking a multiple choice test and you get done with a calculation like this and you look down and there's nothing, no answer choices there that match yours to any significant degree. Well, now you've got to troubleshoot this and find out where the error is. Well, if you did it all as a single calculation, you'd just have to start over. If you've got the pieces stored in 3 registers, you can check each piece against what you've got stored. When you find one that isn't right, then store the new value and go plus recall 1, plus recall the other one, and then get your answer. And hopefully by then you'll find one that's one of the choices for that problem. Now, the second memory function shows the value in memory register 0, and then you can use the arrow keys to go through all of those. Okay, so that mem is actually the 0 key. So I'm going to go second function, hit mem, and it says MO, memory and register 0, and then use the up arrows to go to 9, or the down arrows to take them numerically, M1, M2, M3, M4, right on through. Now you can clear all these registers by doing second and then hitting clear work, which is that second function of the lower left-hand key. down there. Now I've got Y there because I don't know why you'd ever have to change them. As soon as you put something new into a register, it just overwrites whatever was in there before. So I've never had occasion to clear them, but you can if you like. Okay, next function we want to look at on this calculator is combinations. So the idea of combinations is in this example, how many different pairs can be made from the letters A, B, and C? Well, there should be 3 different pairs that we can make from that. And so that's a simple example. It, of course, gets more difficult. As I say, how many pairs are there in 17 or something like that? But this nChooseR function, which is above the second function above the plus key on the right-hand side there, that answers this question, uses the formula. This is one place in which the Texas Instruments calculator has a function that the HP does not. So we just go 3 and then hit that second function and then the plus key to get that nChooseR and then put in 2. So you've really asked the calculator, how many groups of 2 can I pull from an overall group of size 3? And that'll display 3, and those are our 3 pairs. Now notice we don't count AB and BA separately when we're using the nChooseR, the combination function there. So let's look at a different question. How many different pairs are there in 4 items? Well, if we enter 4, take that NCR function, 2 equals, that gives us the answer of 6. Now, when order does actually matter, then we're talking about permutations. So now we're going to count AB and BA as 2 different pairs when we talk about permutations. Because with permutations, the order matters. Well, understand you're going to get a bigger number with permutations than with combinations because we are double counting each pair here with reversed order. So all we have to do, it functions exactly the same, enter 3, take that second function, and permutations are, and then 2, and then equal to display 6. So let's take a look at an example of how that might come up. Well, this isn't exactly a finance application, but should help anyway. If there's 7 runners in a race, how many different ways can runners finish first, second, and third? So now order matters, right? If 3 runners in this order in first, second, and third is a different outcome from those same 3 runners in a different order in first, second, and third place. So now we go, well, there's 7 runners, hit that permutations function, and then 3, and that'll tell us how many different groups of 3 there are in 7 items, when each group of 3 can be different if it's the same items with a different order. So the question here, how many groups could win the first 3 places in any order? And 7, second, and CR, the combination formula, gives us an answer of 35. And the difference between 35 and 210 is that we've multiplied by the different number of ways that we can reorder 3 people into first, second, and third. And so that's 35 times 6. So that's the relation between the 2. Now let's look at our time value of money keys. You'll use these quite a bit. They're in that 3rd row there, and you see that there's 5 of them. And really the logic of it's pretty straightforward. If you put in any of those 4 values, and then you press on the 5th one and press compute, it'll calculate it for you based on those values you put in for the other 4. Now, sometimes as a shortcut, people hit this clear time value of money, and that's out there above the FV, future value key. It's the second function of that. Now, I don't do that on my calculator because I'm always careful to put in 4 and solve for the 5th. So if you're doing that, you never have to worry about clearing it. But remember, the calculator remembers these values even after you turn it off. So just turning it off and turning it on doesn't reset any of these values to 0. So just be aware of that when you're working problems. And I think it's best practices to put in these 4 values. It makes you think about it too. Do I have a payment here? Is there a payment at the end I should put in as future value? So if you look at the mathematics here, what we've got is the present value of some end of period payments. If this is the end of the first period, that's time 1 period from now. And this is time equals 2. This is n periods from now. It's supposed to be equals n there. And then this future value comes on that same date. Okay? So you get a payment, then you get your last payment, and then anything that's left in the account or anything that's left to be paid, that's the future value at that point in time. So we're discounting these at our interest rate. This is the I over Y that we put into the calculator. This is n, the number of periods. Here's the payment per period. It could be 0. And here's the future value. That could be 0 as well. Now, if they're both 0, of course it's 0. But you could have either payment you could have a non-zero payment, a non-zero future value, or both, is what I'm trying to say. So if you put in any 4 of these values in this equation and you're in end mode, then you can calculate the 5th. And that's the essence of what's going on with these keys. Now let's take a look at an example here. We've got a security with a required return of 7%, so we're adding 7% to 1 to discount that. Makes 6 annual payments beginning 1 year from today, so that's clearly end mode, and a payment of $1,000 after 6 years. Those of you with a little financial training are going to recognize this is like the payments on an annual pay 6% bond, or a semi-annual pay 12% bond. But we've got 6 payments here. So let's think of it as a 6-year bond that pays $60 each year, and it matures at $1,000 on the last day, and that's the same day that last $60 payment is made. So notice that our discount factor is the same for the $1,000 and the last payment because they come on the same day. So with your calculator in end mode, just hit 6 and then n, hit 7 and I over y to tell it the discount rate is 7, hit 60 and then payment, or enter 60 and then hit the payment key, put in 1,000 and then hit the future value key, and compute present value. And it solves this equation right here. Notice that it comes back as a negative. The calculator understands, well, it doesn't really understand, but it's programmed to act as if it understands that if I put money into an account for a period of time, I can take money out at the end. In this case, if I've got a bond that's going to pay me payments and pay me the face value, that's why we put those in as positive, then the present value is what I'd have to pay out today to buy those. So that's why the difference in signs. And if you foul up the difference in signs, then many times you'll get error message number 5. And that's just an indication that that's exactly what you did. So as I said, enter any 4 of these values. Present value and future value must usually have different signs, or you'll get this error message number 5. So you can think of it as a company issuing a bond. They take in the present value today and make those coupon payments and maturity payments, so they'd both be negative. Or a buyer of a bond pays out money today, a negative, and then gets the payment and the face value at maturity. Now, sometimes we might want to put the calculator in begin mode. And try and avoid it, but sometimes you do. This is like a lottery payout, right? If you get a lottery payout, you win the lottery. I know most of us haven't, but I still understand how it works if I do. And if I'm taking an annuity, a series of payments for my lottery winnings, the first one will be the day I show up there with my ticket. They're not going to say, oh, you can have your first payment a year from now. Go think about being rich, okay? No, they're not that cold-blooded. They give you the first payment when you take your ticket in. So that's the beginning of the year payment. So now, if we have payments that start today and we have n periods, then here's our equation. I don't want to get too much into the mathematics right now. We're supposed to be talking about how to run your calculator. But in this case, put your calculator in begin mode, put in 20 periods, a $200,000 annual payment, a 6% discount rate, and a 0 future value, right? After you get that last, say you got 20 payments for your lottery winnings, after you get that last payment, there's no maturity value. They don't owe you anything else. So put future value in as 0, compute the present value, and hopefully your display says negative $2,431,623 and 0.298, depending on what rounding you've got in there. A couple more keys for you that come up not real often, but sometimes. Entering a value and then hitting the ln, that's the natural logarithm, computes the natural log of that value. And how might we use this in finance? Well, if we have an investment, we say its holding period return for 1 year was 5.2%. What is the equivalent continuously compounded rate of return? So that's where this log key comes up in level 1. Excuse me. So if we've got 5.2% for our holding period return, right, over the whole year, the value of our investment went up 5.2%. We're going to put in 1.052, got to turn it on as usual, 1.052, and then you see that in the fourth up on the left-hand side, hit that ln key, and I get 0.0507. So a continuously compounded rate of 5.07% would increase the value of an investment or the value of an asset by 5.2% over the course of a year. Now, what about that e to the x? Well, that's the mathematical e, and e to the x says what power do I have to raise e to get this number? And that's really just the opposite of the natural log, because the natural log of e to the x is x, and then if I take e to the x, I get back to that number. So now we have the continuously compounded rate of 5.07%. What is the effective annual rate? That is, with a 5.7% rate compounded continuously, by what percentage would a deposit grow over 1 year? Well, it's just the opposite of what we did before. We're going to put in 0.0507. Now this is the second function above the log key. Hit that e to the x, so second e to the x minus 1, and that gets us back to our effective annual rate of return. So these only come up in this context that I know of, is with continuously compounded rates of return, which are used in continuous time mathematics, foundation of some of our options pricing and things at level 2. So that's why it's in level 1. A couple of miscellaneous keys here for you finally. That arrow key that's right below the on-off. When you punch in a wrong digit, you hit second, hit that arrow key, and well, you don't have to hit the second, sorry. It doesn't matter if you do, but you don't have to. Just hit that arrow key and it goes back 1 digit at a time if you have to correct what you've entered in there. Now remember, again, even when the calculator is turned off, it remembers the entries in all these cash flow functions, time value of money functions, the memory registers, everything like that. And one last key that you may find handy is the second function for the equal key. If you hit second and then hit that equal key, it goes back to the last answer you had. So if you had an answer and you start to do something to it, divide it by something or multiply it by something, and you say, oh man, that's not what I want to do. You want to get back to that, use the second function, and then hit that equal key. Okay, well this is some of the setup and some of the basic things. There's some more calculator functions that we do in another video. It's called the, I guess, advanced operation of your calculator. But set it up that way. That way you'll be in agreement with all our examples and the keystrokes we show in answering practice exam problems and everything like that. So that's it for this.